Polynomial functions with degree 3 and 4. We looked at these a little bit, a couple of them, but let's look at a couple more of them. Let's start with here today, first of all, f of x equals a minus x to the third plus 4x squared plus 5x. All right, what do we know about that one as far as the graph? Well, we talked about last time, start here with kind of like the up and down parabola thing. With these, the third degree and fourth degree, we're going to start with the end behavior. What happens on the ends? Okay, and so this one's third degree. And what do you know about what about that? Third degree, well, the ends, they alternate, right? One is up and one is down. And in this case, which way? Left will be up and the right will be down. Why? Because the negative 1 right here, a is negative 1. And so since that a is negative 1, negative, yeah, its left end is up. Put a graph right here. The left end is up, and then the right end is down. One other quick note on that. I'm not sure the book says it exactly that same way, but that is what happens. It's what's happening at the infinities. They might have mentioned something about infinity as you go out either way to infinity. One of goes up or down. So if you have a question about that, just let me know. But anyway, for our purposes, that's what we need to know, right? Left end is up, right end is down. That tells us what's going to happen on the ends of our graph there. All right. Now, we also then, for the graph anyway, we then did talk about our intercepts. And the y-intercept, start with the easy one here. The y-intercept, you just set x to be 0, as always. And we get y equals, that'd be negative 0 cubed plus 4 times 0 squared plus 5 times 0. Well, that's 0, that's 0, that's 0. So the y-intercept is 0, isn't it? Everything zeroes out. The x-intercepts, well, that's a little bit more involved. For the x-intercepts, what do? We set y to be 0, which in this case, f of x, playing the role of y. So we set f of x to be 0. Okay, and my suggestion here is if this first term is negative, the leading term is negative, I say let's move all the terms over. So I'm going to add x squared to both sides, add x cubed to both sides. I'm going to subtract 4x squared from both sides. I'm going to subtract 5x from both sides. Just move all the terms over, change their signs, and makes it a little easier to factor if we do that. So now we can factor. We've got a GCF, don't we? Everything has an x in it. So we factor off an x. So that'll leave parentheses x squared minus 4x minus 5. And then that trinomial factors nicely, doesn't it? Got x squared minus 4x minus 5. That would factor as x and x. What and what? Well, with minus 5, minus 4 in the middle, 5 and 1. And since it's minus 5, one of them's negative, one of them's positive. Which one's negative? The 5 would be negative, the 1 would be positive. Yeah, that would add to be negative 4. Okay, with me on that. So then we said x equal to 0, x minus 5 equal to 0, x plus 1 equals 0, as we have done many times in the past. So that's one of our x-intercepts. Add 5, you get x equals 5. It's another x-intercept. Subtract 1 here. Got another x-intercept. So there's our x-intercepts. So putting those on the graph here, we've got y-intercept of 0. X-intercept is 0. Of course, that's the same point. X-intercept of 5, which I put right there, and then an X-intercept of -1, which is going to go right about there. Which gives us a little more to go on, but not quite enough here. I'd like for us to get a little more to go on. My suggestion then for the next step is we've got these nice X-intercepts, but those are just right on the X-axis. And so let's get some points between my X-intercepts with a little table here. Yeah, let's do a little XY table here. And get a few points going between the X-intercepts. Yeah, so this is -1, this is 0, so I'm going to have to go maybe a decimal to get between there, but -0.5 is pretty good choice on that one. And then the other X-intercepts, between the other X-intercepts, between 0 and 5, like I said, you can do anything you want to in there. You can do more than one if you want to in there, but I would say let's go somewhere in the middle, so let's just go with 2 or 3. Your choice. I'll go with 2. Small. So if I can find the y values to go with those, yeah, that'll give me some good points to work off of. So let's do the -0.5. So just plug in -0.5 everywhere. So that would be a negative of -0.5 cubed plus 4 times -0.5 squared plus 5 times -0.5. Yeah. What does that give me? Well, this is going to be, do the cubing first, so it's going to be negative, well, that's going to be a negative, is it 125? 0.125? This is going to be 4 times, do the square first, so it would be 0.25 positive. And then this will be minus 0.25 when we multiply these two together. I believe is accurate. 0.5 cubed, isn't that 1.125? 0.5. Hopefully I got the, yeah, 0.12. All right. So we've got a negative and negative. That makes a positive 125. That'll be 1, and then minus 0.25. So altogether, not a very big number there. Let's see. Is it point something something? 0.125 plus 1 minus 0.25. .875. Does anybody else get that? 0.875. So yeah, it's not a very big number at all there. Okay. Now when x is 2, a little bit easier, no decimals there. So it'll be negative 2 cubed is 8, plus 4 times 2 squared would be 4, and then 5 times 2, so that's negative 8, plus 16, plus 10, and that is a bigger number. That's 18, isn't it? So 218 and negative 0.875. Okay? Does that sound all right? All right, so here's is that for some reason that doesn't sound right.
Would it be 2.5?
This right here?
On that 5 times 2.5?
Oh, 2.5. Yes, that's where I messed it up. Thank you. All right, so yeah, let's see what that gives us. So it is not 0.875. I knew that didn't sound right. All right, 0.125 plus 1 minus 2.5. Yeah, that's better. Negative 1.375. All right, so just checking you all to see. Just paying attention there. No, I messed that one up. All right. That sounds better. All right, so negative 1.375 is down here, at negative 0.5 for there. Then at the other side, 2, I'm at 18. 1, 2, 3, 4, 5, 6, 7, 8. Go up a little further. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I think I'm way up there. At 2, I'm at 18. Okay, so yeah, with the end behavior and then those points and the x-intercepts, I think I got it. All right, so here we go. End behavior up here, then it's coming down through there, coming back up. Probably goes a little bit higher there. Probably get the 3. We might see that, but with me there? Get all those points and kind of see what's going on. Question or concern? All right, let's do here a 4th degree one. Everybody's got that one? Do a 4th degree. All right, the 4th degree one I want to do is this one. F of x equals minus x to the 4th plus 5x squared minus 4. All right, so we've got a 4th degree. Start with the end behavior. How does 4th degree end behavior behave? Well, on a 4th degree, they're either both up or they're both down. And in this case, we're going to go with both down, yeah, because the a is negative. A was positive. Again, a is negative 1 there. If a was positive 1 or positive 2 or anything positive, it would be both up. This one, though, has a being negative 1, so it's down. Both down. All right, then our intercepts, the y-intercept, well, in this case, is not 0. The y-intercept is going to be, when x is 0, that's 0, that's 0. So the y-intercept is, looks like negative 4, doesn't it? What about the x-intercept? Well, we said f of x or y to be 0. And so we wind up with this equation looking like this. How am I going to do that one? Well, again, my suggestion is since a is negative and we do have equals 0, we can move these around now. And so let's move everything over to the left side. Add the x to the 4th, subtract the 5x squared, and add 4 and get it equals 0 on the right. Okay? And so that will enable us to work on this a little more. How am I going to do that? There's no common factor in that one. So let's just try factoring it. We do have an x to the 4th, so I'm going to have to break it down as x squared and x squared. With minus 4 on the end and minus 5 in the middle, how am I going to do that? How about minus minus for positive 4? We could do minus minus 4 and 1, and that would give me minus 5 in the middle. If you add those together, you get minus 5. Okay, so now let's set those separately equal to 0. Yeah, this can work out nicely. Square root method used here. If we add 4, then square root both sides, it's going to be plus or minus the square root of 4, which is plus or minus 2. This one, similarly, add 1, square root, plus or minus, so it would be plus or minus 1, wouldn't it? All right. So that gives me some intercepts to go. graphing with. All right, so we've got both ends down. -4, y-intercept, -2, +2, -1, +1, x-intercepts. All right. So let's then get some points between the x-intercepts. Well, kind of limited here space-wise. Between -1, -2, let's go with -1.5. We've already got a point between -1 and +1, 0, and then between 1 and 2, let's go with 1.5, and I think it'll work out nicely here for our y values. A few decimals, but that's all right. So what do we get if x is -1.5? That'll be -1.5, negative of -1.5 to the 4th, plus 5 times -1.5 squared, minus 4. If we can figure that out, we'll have our y value there. Let's see, -1.5 to the 4th is 5.0625. So it'll be negative of 5.0625. Again, we're squaring, fourth powering and squaring first. That exponents come first. -1.5 squared is positive 2.25. So if I do a negative 0.506 plus 5 times the 2.25 minus 4, I get punch it in right. 2.19? Anybody else get 2.19? Okay. Well, like I said, we've already done 0 between it. That, you can do it again. It'll be -4 either way you go there. Then at positive 1.5, well, notice on that I'm going to get the same answer, aren't I? As I did for -1 point. I believe so. That's going to be a negative 5.06 again. That's going to be 5 times 2.25 again, minus the 4. Yeah, I'm going to get the same thing I got there, 2.19. So those two, -1.5, 2.19, positive 1.5, 2.19. So what's the graph look like? Well, you got this down here, then it's coming up, going up about there, probably turning around close to there. Then coming down, coming back through there. So it's just kind of a up and down deal, like that. Sound okay? Everybody believe that? It looks pretty good. Question or concern?